Okay, so this is the algebraic proofs foldable. So it's a little funky to set up. So what you need to do is you need to cut it out first, and then you're going to stack the 2 pages. So if you lay it out to where, so the pages you'll kind of offset. So like one page will be like this, and it will say, have that square and say algebraic proofs on it. That'll be one page. And then underneath it to where it's sticking out just a little bit, so like you can't see it back here, but this is the other page. And it'll stick down just a little bit so you can kind of see where the title is. So the second page that will say vocabulary. And you stack them up like that. And then if you fold them kind of right here, they will create this stack you see here. So when it shows up, you should have like a shorter tab that says algebraic proofs right here. Then the next shortest tab is vocabulary. The third tab is practice with properties, and then algebraic proofs. Okay, and I would fill it out before I glue it in. So when you open up the cover, we have this information. So we're learning about proofs. A proof is a formal logical argument that shows a statement is true. A 2-column proof consists of statements, that's the left side, and reasons, that's going to be on the right side. So the statements are the left column and are the result of applying definitions, postulates, and theorems to the statements already made. The reasons are the right column, and they are the justification for each statement. They're like the reason why. Why does it work? Why is this okay? And if you could squeeze just down there in the corner, a 2-column proof has a statement side and a reason side. And then we would have stuff filled in down here, but that's just our little example. Okay, so now if you pull back the vocabulary tab, you have these properties tab. Let's see here, that's under practice with properties. So properties to use. So we've learned all these properties in the previous video. We have them in this foldable right here. All right, so we are going to practice with these properties. So go ahead and turn the page on the vocabulary, and here's some examples. So let's start with example 1. If measure of angle A equals measure of angle B, and measure of angle B equals measure of angle C, then you can drop the angle B and you end with measure of angle A equals measure of angle C. That is the transitive property. And there are equal signs, so it's the transitive property of equality. And please make sure to just go ahead and put the whole thing, not just transitive. Okay, xy equals xy. All right, so if we were to go back and revisit this foldable back here, we learned that when it says the same thing on both sides, that's the reflexive property. And there is an equal sign, so we're going to say the reflexive property of equality. All right, on line 3, if 3x equals 6, then x equals 2. Well, if you notice, we started here on the if. How did they go from 3x to x? How would you move that 3? All right, you would divide both sides by 3. That's how you got to the x equals 2. So you divided both sides by 3, so that's the division property of equality. Okay, so look at number 4. If 2AB equals BC, then AB equals half BC. So somehow they moved this 2. So how would you move this 2? All right, you would divide. So if you divide both sides by 2, you'd have AB equals, I have BC divided by 2. That's the same as half BC. So now I'd be okay with division property of equality, but another way to look at it, and probably the more correct way, and I'd probably count you right either way, but another way to look at it is instead of dividing by 2, you could also technically multiply by a half. And so really, this is probably showing multiplication property of equality. That would be the most correct answer. But in all honesty, on this one, I could see how you would think division. So because they show it as BC times a half, that makes me think multiplication. If they had shown it like this, BC divided by 2, that would make me think division. All right, number 5 says if 2 equals x, then x equals 2. So you're just reversing the order. That is symmetric property. Symmetric is where we can just switch the order. Some symmetric property of equality. All right, 6 says we have 2, and then parentheses x plus 5 equals 2x plus 10. We are distributing there, so that's the distributive property. And on distributive property, there's not a distributive property of congruence, so you can put of equality or you can just leave it. I'm only kind of picky of the property of equality when it could be equal or congruence. So property of equality is great, but on distributive property, there's only one, so that's why it's okay just to write distributive. Okay, let's do number 7 together. If AB plus BC equals 10 and BC equals 4, then AB plus 4 equals 10. So what I think they did was they took this 4 and they plugged it in where BC is. So that is substitution. Okay, so you are going to go ahead and pause the video and complete these. And after that, I will post an answer key of what these should be. So you're going to complete the remaining, sorry guys, you're going to complete the remaining problems, number 8 through 16, and then I will post a picture so you can fill it out. But do try to complete them on your own because we will have lots of questions on these on the upcoming tests. Okay, so now if you flip the page and you turn back to algebraic proofs. Algebraic proofs are really easy. It's just justifying an algebra property. So your first line is always given. All right, because that's what you were literally given to start the problem. So now you just look at how did they move between each line. So from line 1 to line 2, they distributed the 5. So that's distributive property. All right, now how'd they get from line 2 to line 3? So from line 2 to line 3, they subtracted the 10. And they don't show that. You just say that's subtraction property of equality. Okay, and then how'd they get from line 3 to line 4? Well, they divided by -5 on both sides. So that's division property of equality. All right, let's try another one. So what do you always write on the first step? All right, you always write given because that was what was given at the beginning of the problem. And I will tell you, people like to write prove on the last step. You never write prove in a proof. Okay, it's never a reason. Don't ever write prove. All right, so we got to know how they get from step 1 to step 2. So if you notice, they still have the 8x, they still have the 6x. So they had to move either the 7 or the 5. It looks like they added 5, and that's how they got the 12. So that's the addition property of equality. And you don't have to show the things I'm showing right over here if you don't want to. If you can do them in your head, you can just write the steps down. So now to get from line 2 to line 3, they subtracted the 6x. And that gets me 12 equals 2x. So that's subtraction property of equality. And then they divided by 2, and that's division property of equality. All right, and then they went 6 equals x, and they said, hey, if 6 equals x, then x equals 6. So when you're just switching the order, that is the symmetric property. And it is an equal sign, so it's the symmetric property of equality, not of congruence. Okay, so you have 2 more proofs left, all right? So you have this proof, and then you have the last proof. So you're going to go ahead and complete those as your homework, but I will post an answer key at a later time.